Hi everyone. Good afternoon. Okay, let's pray I can be able to do this. It's been a while. Great to be back at DevFest Lagos specifically. And like she mentioned, my name is AUWAL MS, and we're doing a very, very interesting conversation. Before we get started, how many of us have visited a site? How many of us have visited a site and then the site the site has like an AI feature that is able to answer a question related to what is on that site? Okay, so thank you. At least we have a couple of people. How many of us have read the Money Point informal sector report from 2025? So we recently launched a informal sector report, and one of the features that is available on that report is an AI toolbot that is able to respond to questions with regard to what is on that doc, right? So we're talking about building something of that nature. The topic is there, building well-grounded AI features into your application using your own data. You know, on a normal day, you have systems who have AI features enabled, but you ask questions and then the response you get is totally different from what you're expecting. So we're talking about how you can build something that will be able to like respond based on what you have on your doc. So your responses are related to everything. So my name is AUWAL MS, and I currently lead the developer relations and technical integrations team at Team Apps or Money Point, depending on how you want to look at it. And that involves supporting people, developers who are trying to integrate into our payment gateway, known as Monify, that allows businesses to receive payments seamlessly across the country and hopefully across the world very soon. If at any point in time you have a question that I'm not able to answer due to time or anything, feel free to drop me a message on Twitter. My DMs are open, or on LinkedIn, and the name is AUWAL MS. So yes, anyone can add AI features to the application, but then when you add that functionality, one of the biggest problems you have is that the AI tool now gives wrong responses. May not be wrong, the response will probably be related to something totally different from what you're looking at, because it doesn't have good information into what is happening on that side. And this is mostly because it has outdated knowledge. Maybe at the time where that AI feature was trained, you had version 3 of your documentation. And now you're coming to, maybe your team released a version 4 this morning. The AI tool has not been retrained with the new tools, with the new information, and is requiring to like respond to questions. The requests that you get from your user are totally different from what they're expecting. So the biggest issue becomes, the response becomes out of date. Another thing is you're building a feature that users are asking, they want information that's related to what they have. But then the AI tool does not have private information. It doesn't have the private context of what you're asking. And then it takes us to the last and very, very big issue. When it tends to respond, it does not tell you. If you ask a human being a question about something that they are not aware, they don't really have context on, they will tell you, I'm not really sure, but I think it's this. In the case of AI, the response will sound very, very real. It will have confidence, like very, very high confidence level, even though it's actually saying it in error, right? So these are majorly the 3 issues you have with just adding AI to your functionality to your application. But then how do you solve this thing? So that is where RAG comes in, Retrieval-Augmented Generation. It's basically an architectural pattern that allows you to provide additional context to an AI tool so that the response they give is grounded on that specific things that you're providing service for. So it's very, very simple. You give it additional context. That way the response is based on the context that the tool requires to be able to like answer your questions correctly. So what is RAG, right? Follows 3 different principles like you've seen it, like the title goes. First is retrieval, fetch, right? It goes fetch the information that it needs to. But before it goes to the next thing, it arguments that request, the context of what the person, your request comes with the context of that document or that, content that you have, that local context. It arguments everything and then generates a response based on the question and based on the context that was provided to it. So that's basically what RAG is. But then it's very, very simple to say. Everyone could say, hey, we could just add RAG to our project. But then it also comes with its own problem. It's not that straightforward. It's not an app you download. It's not just a tool. It's not just a library you plug, right? It has a couple of things that you need to do. First, you need to prepare the data. Documentations could be 1,000 pages. Documentation. If anybody has ever read Java 8 documentation, you know what I'm talking about, right? It's that verbose, right? So you need to prepare. Also, sometimes these informations are not in the same file. They could be in the form of images, they could be in form of PDFs, they could be in form of documents. So you need to be able to prepare those documents. And then orchestration is also something very, very critical. What does it need to do? What should I do first? What should I do next? And what should I do afterwards? So this logic is also something that you have to have good understanding of how things work to be able to write them. Then the big issue is you're writing a code, right? You're trying to build your own AI model or you're trying to build your own RAG in this situation here, but you cannot really tell if the response you're getting is accurate or you can tell if it's accurate or not, but if it's giving an inaccurate information, you can't tell why is it not reading your context. That is one very, very big issue. You cannot debug. We only debug problems if we see that there's an error, right? It's usually, we find bugs before we debug. You can't debug an empty file, right? Which is usually why we say developers are the people who introduce the bugs to an empty file, and then you end up saying you're spending time debugging when you're the real person who actually created the bug. So yeah, so debug is really, really hard in local environment because you can't even tell. In short, even when it goes to production, you can't tell why it's failed and how do you fix it. Then the next thing is how do you deploy it, right? Deployment is also a very, very important problem. It's a good problem to have, but then we know what it costs to be able to build your model, deploy it, and things like this. So these are the core things, the 4 core problems that we're looking at. How do we have a service that makes it very, very easy to be able to achieve this? So I introduced to you Genkit. So Genkit is actually an open source framework specifically for backend that allows you to be able to build very, very grounded RAGs using your data. Your data could be in Firestore, for example, or could be anywhere. The good thing about Genkit is that it has support for local development. You can easily deploy things to simple servers like Cloud Functions, and then monitoring is very, very possible with it. As you build stuff, you can be able to monitor them right from your development environment and be able to tell why they're working or why they're not working. So let's take a look at a couple of things around it. First, I mentioned it's a backend framework, and the core languages of support currently is actually Node.js and Golang, right? So it's very, very simple. And then the way it's written is it is developer first. So local development, you can be able to build these things, see them locally on your system. You have a UI, so you don't necessarily need to be checking stack trace. You'll be able to see the track trace, right? But then it's on the UI. So it's much, much easier than for you to be able to look at it from a, command line. Another thing about Genkit is that it has a plugin architecture that allows you to be able to mix match many different models. So you don't need to worry about, hey, must I use Gemini Pro for everything? What if there is a part of my code that I want it to go to cloud? Or what if this type of task should be solved using OpenAI, right? Or yes, I want everything to go to one model. So it has multimodal support, and makes it possible for you to be able to like use multiple models. Your data source could be anywhere. It could be on a cloud storage. It could be on Firebase, on Firestore. It could be anywhere, right? You can even use local data. If you're the type that likes creating embeddings and putting them on PG vector, right, that also has support for that. The most important thing is deploying it is very easy. Why? Because the models you write, or the logics you write in this case here, in the case of Genkit, it's called flow. The flows you write are small functions that can be deployed independently. We'll take a look at how it looks like to be able to like write a simple function. Genkit has 4 core concepts that they follow. Like I mentioned earlier, it has flow. And flow is like a function, a deployable function. You can write flow for this, and then it moves to this, just like you can see in the illustration here. And like we mentioned initially, it has support for multimodal. So you're not locked into, because it's a Firebase product, you're not locked into Gemini. You're not locked into Google. You can be able to use any model that you prefer for the tasks you want it to do. For retrieving, the R in RAG is for retrieving, right? For retrieval, right? So Genkit, as a way of achieving RAG, has a retriever function that allows you to be able to like fetch content or fetch context from your different data source. And finally, if you want to create your own embeddings, if you've been building stuff that have to do, if you've even ever built a functionality called semantic search, you know to do a search, you are supposed to create embedding. Those embeddings make it easy for you to be able to like fetch things that are related to each other. So Genkit has support for creating embeddings and saving them as indexes in an indexer. Next, let's take a look at what a common architecture of Genkit looks like. So you have an app. It could be doing literally anything, right? And you want a user goes to your app and makes a request. It includes a context. Okay, hey, for example, you have an e-commerce platform and you have lists of items you sell. And a user visits your site and is saying, hey, I have a wedding on 13th of December, and I'm wondering what sort of shirts or what sort of dressings should I purchase from you that would be perfect fit for this situation. When they click on that submit button, what happens is that your request now moves into Genkit, and Genkit first calls the retriever. The assumption is that you have a product DB, a collection, or in this case here, because Firestore uses NoSQL DB architecture, the assumption is that you have a product catalog on your DB that has lists of all the things you have available. AI will try to suggest things, but it does not know what you have. If it tells your user to go and buy agbada and then you only sell English dresses, it defeats the purpose, right? It can take, the request goes to Firestore. If it is a structural data, it goes to Firestore, go to the Firestore retriever, fetches those information based on the user's data. And then once it gets that context of list of things that are available for you, it passes this information together to Gemini or Cloudy or any of the OpenAI models. And afterwards, once it fine-tunes everything, it returns a response to your user. So that makes it easy for it to suggest things that you have available, not things that are imaginary. So let's look at what it looks like to create the retriever. You remember we said the request goes to a retriever, the retriever fetches the content that you have on your product DB and be able to return it. So if you look at line 1, it's basically very simple. The assumption is you've already done npm install Genkit AI on your system, right? And basically the first line is just importing the content. As it imports the content, it also goes to using the Firebase admin to be able to like import or use Firestore. The next thing on line 5, and as well as any other embedding are there, but most important thing here is that function you're seeing there. It uses the defined Firestore retriever, and what that basically does, it goes to Firebase and try to retrieve this from your DB. You specify the name of that retriever because it's important the next time you're trying to use it. Right? So import the retriever, specify what it is. Very important things to see here is that we are able to specify the collection because like the collection in this case here, for database, for SQL users, it's basically specifying the word table, right? In the case of NoSQL or in the concept of Firebase, everything is saved as a collection, right? So it goes to the collections and go and check the collection with the name product list so that it can be able to like get context of what it's looking for. Inside that collection, right, we expect that you have, maybe you have a node in the document called embedding, which is what you're seeing the vector field here. So it's very, very simple to be able to like build this. So this is what the Firestore retriever looks like. And then, so you've created the retriever, and now you need to be able to like use the retriever to fetch content from the user. So this is where the flow comes in. You can see these are basically small functions that will be able to do things. The comment you see on this document clearly says what it does. First up there, we are calling three different features that are available on Genkit core. The define flow, which is used to create a flow, right? We also have the generate, which is used to be able to like prompt the model to tell it that, hey, we need you to generate this. And then the final one being retrieve, which is used for a retriever from your own DB. You remember the name of the, the retriever we created earlier. If you take a look at line 14, you can see what we're doing. So you can see from line 10, you can clearly see that it's a function, right? And it takes in the query. What is the query? The prompt that your user gave on the UI. And then the next thing is it goes to retrieve. It takes the query and goes to the retriever and specify, okay, what retriever are we looking for? The product retriever that we had created initially. If you can see line 8, the name of what we created is product retriever, right? And then afterwards, if you go down, you see the next line, line 17, is us fine-tuning the context. What gets returned may have multiple new lines. We want to trim out everything and make it just one single line, which is what we're doing. And then you can see from line 19, we're telling the model to only use this context, right? Only use the following context to answer the user's question. So you don't want it to go wild, right? Don't be imaginary. Using the content that I have on my retriever, respond to this person. We specified the context, which was what we defined earlier, and then we also specified what the question of the user is so that it knows what it's supposed to respond using. Then the response gets, then you can see the next line here on line 25, we're using the generate function we had called initially. You remember I told you the generate function basically tells the model, go and do this, generate this. On the next line, which is line 26, you can see we have the model there. We're specifying what model we want it to use. We just wanted to use Gemini 2.1 Flash. That is what we want to use. And you can substitute this with OpenAI. You can use DeepSeek or Llama or anyone that makes sense for you, right? And then the prompt is what the prompt that gets to the model in the long run is what we've been able to concatenate everything in line 19. The response that gets sent back to the UI becomes the response.text. So you are not just telling you're not just telling your code or Gemini or any other of the AI models to do this. You want them to know what you want them to use to respond. So it's not going to be a surprising situation. Okay, so what is now the problem? So we've done everything that we need to do. You remember I mentioned that one very good thing about Genkit is that you are able to see why A is working and why it's not working. You can be able to, like, we're going to see a picture of what it looks like on the UI. The most important thing about this is that you can tell why your code is failing. It is not just failing because it refused to work, or it's not returning the wrong response even after you provided the right value. So we're trying to see how it looks like. So yes, You can start Genkit locally, so it means you can test your functionalities locally in your system. And your browser, you can be able to test it in your browser, you can see how it's going. You can be able to like view a clear stack trace of what is happening at what line and everything. So it's a very, very full augmented grounded prompt is what gets sent to your LLM. The basic benefit here is that you can definitely confirm if your retriever is working. Because ideally, if your retriever is working, it will have all the context it needs to be able to like respond clearly. And this is what it looks like, right? This is what the UI looks like if you're running it. You can see there's a customer agent. This is it doing a generate function. Here it's using Gemini 2.0 Flash, and you can see it. So you can clearly see, okay, I have the location, I have the IC locations, and it lists out everything based on the document. Up there is the prompt. Give me a honeypot recipe, right? So it's a case of everything gets clearly listed. You can see your prompt. You can see the flow output. So the step-by-step of everything you want it to do, you can be able to see it. So it's not going to be like magic or something you don't totally understand. If you want to practically try this out to see how it works, if you want to check out Jenkins, please scan the QR code we have here. It's a code lab. It's a self-paced code lab. I do not expect you to use your laptop here, so I make this a QR code for you to snap. It takes you to a self-paced code lab that will probably take you 30 minutes to 1 hour to complete. But you'll be able to practicalize every single thing we've covered in this session. So yes, so in summary, right, the summary of it is a back-end first framework, and it has TypeScript support for like primarily it's TypeScript support, and it also has Golang support. I know ideally we'll probably say, hey, what's an AI model without a Python support, right? So yeah, Python is on alpha phase. You can try it, but please, you're not ready to go live on it, right? But yeah, there is support for Python. It's in the work, right? But strongly type environment. The fact that it is actually Firebase native, it makes it very, very easy and possible for you to deploy it to Firebase Cloud Functions to be able to like, try. One good thing about it, like I mentioned, is that you can test things locally and know why they are working or why they are not working. And if you're worried about, is this production ready, can I monitor it in action? We've seen the previous slide where we've seen how you can be able to like monitor this thing as it goes. So that is it for this session on Genkit. Thank you very much for your time.
Okay. My name is Nathan, and in the code example you showed, I didn't see any option for an API key. So let's say, for example, I want to use OpenAI, which actually requires an API. Where do we add it to the model we want to use? And can we perform further configuration for this particular when we want to use a model?
Yes. Okay. So I was trying to make this slide as small as possible, because if I was going to write the full function, so yes, there's a config part they're supposed to add. The part here only deals with defining a flow that generates a request. For validation and authentication of your keys, you will write a separate flow for that. Like I mentioned, flow is just a function. You can write many different functions that get called before this gets here. So yes, you can be able to like specify your keys if you require key to it. So I just try to trim it, because it's supposed to be longer than this, and I wouldn't want to be sharing something not clear.
Thank you all for that response. So my question is this. When you started your presentation, you mentioned that the flows, right, you can create them as individual functions and then deploy them on Cloud Run. But during the presentation, I think it's even open now. I don't think you mentioned an instance where you have, I'm just assuming this is one particular flow, right? So this would be one function. So what scenario would you like, can you create a scenario where you have like different flows for different functions?
Okay, so hold on, let me come back here. So let's take a look at this example here. So this here, in this second phase here, we're using a NoSQL DB. Imagine a situation whereby you have content in your DB, you also have content that are unstructured in such a way that they could be images, they could be PDFs, they could be any different documents, right? And then you want them to be able to like merge, you need to get to the context of each one of them and then merge them. It means you're going to be able to write another step, right? It allows you to write multiple steps. And then the final step will probably be the one that gets to concatenate everything before it gets to the context, right? So I just, like I mentioned earlier, initially, I think for people who saw my slide as of yesterday, I wanted to do a fork in the road in such a way that if it's structured, it goes to the Firebase store. If it's unstructured, it goes to a local, what do you call it? Any of the vector search DB that you're using. You remember I mentioned something around PG vector, right? Which is Postgres support for vector embeddings, right? So if you have them in multiple places, you can write multiple different steps for them. But then the only thing, what you try to do is you have another flow that merges the two functions, or basically concatenate the two contexts that you get responses from, so before you send it to your model. Hope that answers your question. Okay.
Thank you.
Oh, okay. Go ahead. Sorry.
Yeah, thank you very much. So my question is basically about the current solutions we have just before Genkit came in, like LangChain and Llama Index. These solutions don't actually do well in terms of scaling. So I want to know how Genkit does it better than these solutions that it's trying to kind of replace.
So I think I missed one of my functions, one of my slides. Somehow I missed it. I didn't expect we'll get to this, but like, so like I mentioned, right? If you're worried about scalability, the example I used here is that you can deploy things toward Firebase Cloud Functions. Firebase Cloud Function is very scalable, and I think the good thing about it is it can scale to 100, and it can also scale to 0, right? So the good thing here is that this is going to be run within Google Cloud functionalities. And I feel like saying this now. How often do you go to a shop and want to pay something and you're given a blue POS and it failed? So at least you've seen how GCP, how the scalability works. And then like in the past when we want to check if the network is working, now we do fast.com to check if it's fast. In the past, where do you go? Google.com. If it opens, then all is well. So yes, you can deploy these things on Google Cloud runtimes, and then it will be very, very scalable, right? So yes, this is just like LangChain, but then specifically customized for Firebase and is able to like deploy on Firebase-related, Google Cloud-related for infrastructure.
To be our last question, because we need to call the next speaker. So after he asks, if you still have any question for AUWAL, you can always meet him outside the hall later.
Just like LangChain, Llama Index, and many we have, there's one similar problem most of them have. After building your RAG applications, you might be struggling with if it's really giving the correct answer. Most of the time, it might even give the correct answer, but it's not giving the full context, not even saying a lot of things about it. So does Genkit has a feature that helps you test answer relevance, make sure that the answer is given is what the user actually asks for, or what is given the user is also important. Does it have such feature that can also help?
So, one very important thing with QA for things, right? Ensuring the quality of the stuff, it's dependent on how you're testing it. The very good thing about Genkit, like I mentioned, is you're able to test it in development, right? You have a UI that you can be able to see the steps. I think the most important thing for you is to be able to like write the step, right? Or the flow in this situation here. A flow that checks and ensure that the context that is given is correct. It is not solely the function of the library you're using. It is also partly your own responsibility to ensure you write that flow. You remember when I mentioned everything is written as deployable functions, right? So if you write it as a very clear function, you can always be able to like write a function to check if the response is correct or not. So if your context is not taken into note, you can see it within this flow, right? If it's taken, it is noted, and then the response is wrong, then something is wrong somewhere. But the most important thing is you can debug, right? If you can see why it's failing, then you can be able to like solve the issue. But yeah, Jenkins, which is one of the things that we mentioned, Jenkins allows you to see it working and to see it not working.
I mean,
right?
that means it's highly customizable.
Yes, you can. You're writing the function yourself. You can see whatever you want to see. If you want to see what you're not supposed to see, it's up to you. Thank you very much.
Please, another round of applause. You guys already know I'm going to ask for it. Okay, it is almost a wrap as we move on to our final